We're talking to Swapan Nag, and he's going to be talking about Nag Inc. and their team. They're a geospatial engineer, and they are a data collection team. And the section that we're talking about today is real-time geospatial engineering, data integration, and quality assurance. Swapan, how are you doing today, sir? Oh, I got you muted. Hold on one sec. There you
go. Okay, can you hear me now?
Yep, good to go.
Okay. Thank you, Nathan, for giving us the opportunity to speak. I'm totally impressed by the progress you've made over the years. Nathan and I have been working together on a number of different areas for the longest time. When he first started at the Salton Sea, we visited the area together, and it was a very pleasant experience for me. Of course, most of our work comes at a stage when we've got some real data to work with. And for example, at an early stage when we're modeling and preparing scenarios, I think, Nathan, you remember what we did for Lanai Island in Hawaii several years ago. I could show you the video of Lanai. What was very interesting was the fact that they had planned these wind farms at the time, and it was going to ruin the island. It was a huge wind farm that can I present my screen here?
Screen share at the bottom there, yeah.
Yes, let me click on the screen share before I.
That was my first experience in Google Earth Pro, trying to plot all those different locations. I had the perfect video where we were flying next to the blue whales and the dolphins coming out of the water, and I don't know what happened. I think my computer crashed, so that never ended up being the final product, but it was a lot of fun to work on. That was a great opportunity. Thank you for having us participate in that.
Yeah, I'm going to switch on the volume here.
It has enormous energy challenges. Remote, isolated. It has the highest electricity rates in the country, with a big reliance on oil. Hawaii depends on oil for 92% of its energy needs. $1 billion cable system will be buried underground, under the sea. The energy generated would come from the two islands of Molokai and the island of Lanai. But the energy will be sent over to the highly populated island of Oahu. For the island of Lanai, that would mean a quarter of the island would be blanketed with these wind turbines. Wind turbines would consume up to 22,000 acres of land.
We are a people tied to the land. And that land, which they refer to as wasteland, has a story. It cries to us for care.
This is the way the island looks from the air now. But if the project goes forward, this is the impact the industrial wind facility will have. That's because a wind turbine is like an octopus. Its tentacles branch out far and wide. The yellow lines are some of those tentacles. They represent all the roads that will need to be put in. The red dots indicate how many turbines will populate this part of the island. In addition, a batch plant will need to be built to mix the concrete for the turbine pads. The holes for the cement pads will be immense. In fact, the holes will be so enormous that you could stuff 3 double-decker buses into each one.
I wanted to show this as a consequence of the previous presentation. It just struck me that it's not enough just to model and share the information among ourselves. Very as important is disseminating the information to a broader audience, in the sense that they are warning signs put up to see that all the stakeholders share equally in the input of what the consequences of environmental impacts are. And in this case, we deliberately showed the extent of the pathways that would connect the wind turbines, because all of this sedimentation would have ended up in what is a very pristine birthing ground for whales. This is one of the very precious resources that this area provides for the whole world. And whales come down all the way from Alaska to have their babies in the waters that you see beside this island. And sedimentation would have just wiped out their existence. I'm going to ask Mo to speak a little about.
I'll just share my screen as well.
Okay, you can. This is this stuff is. Oh, you want to share a screen, Mo? Let me stop.
Yeah, I can share.
Okay, go ahead.
To make sure I haven't done the Zoom. I don't know if you're able to. Asking me to allow preferences. Are you able to see my screen?
Not yet.
Okay, because my Mac is not allowing me to share my screen.
Okay, let me share it again then, Mo.
Yeah, I'll change it.
I wanted to just talk about that briefly too, because when you guys first called me, I said, "Oh, that's a great project," right? My first intuition is, "Hey, renewable energy, right? What a great benefit for the islands." And then as we talked and as we moved through it, is you need professional project management and you need holistic thinking when you're plotting a project. And that's the whole discussion piece that we're having with this 3-day event, is you need to know every aspect and you need that community engagement. And there's a way that you could do renewable energy, but it doesn't involve an underwater cable that is going to go through that habitat. There's a way that doesn't involve the sediment. So you converted me into responsible thinking and professional project management.
Thank you, Nathan. I should mention that after that documentary was published and broadcast, the entire project came to a grinding halt, and the owner, who was a bit of a crazy guy, ended up selling the island to Larry Ellison, one of the owners of Oracle. And Larry has now, he's developing a more conventional sense of development at that in that area. So
I'm back.
Okay, you're back. More.
I can. You want me to talk about the presentation?
Yeah, just talk a little about.
Okay, so let's go. If you can go back a couple of slides real quick. I didn't mean to.
Okay, I'm going to start from the beginning again.
Okay.
Let's see.
So, yeah.
Wait.
So we've been so we've been at this game for a long time. Mapping, visualization, analytics, analysis. I mean, it's second nature to us at this point. We've been around for 30 years. So actually, let me see if I can also show my screen now, if you don't mind. That way I can control.
Okay, I can move forward too, Mo.
Okay, yeah. So we pretty much integrate across legacy systems and real time as well as static content. So we're a data company. So we're not just a geospatial company. We're a big data company. We analyze, integrate, share, and organize information in a way that it can be distributed and used, right? So what's been happening in the world today is that there's so much information, and it's very hard to define what's real and what's not, what's accurate and what's inaccurate, what's visual and what's actually representative of the real aspect of the study. And as scientists, most of you already know this, that a visual representation doesn't always depict the actual nature of what is happening. So what we do is we take large amounts. Okay, let's jump to the next slide. So we take large amounts of information and we organize it, and that information can be static, dynamic, and we've done it with really small organizations like little municipalities to individuals that are looking to do projects like the Lanai project, to large agencies that are global. Our projects have taken us all the way to Mars, where we're mapping Mars based on imagery that's existing. We work with Google as a partner to map out Mars. We did it for the moon. We did several different projects for JPL, which we'll talk about. And then the idea is that we've worked with different aspects of information. So it's not just in agriculture, it's not just in utility, it's not just in specific aspects. We take information from across the board, and we allow users to share that information in a way that it's secure. So if you have multiple companies like we have here sharing information, like for Department of State, one of our projects is that you have 100, 200, 300 companies sharing information, organizing, planning activities, live, real-time activities, static activities. And we organize that in a way that, those companies are not sharing what they don't want to share. And they're only sharing with individuals, not entire organizations where you're just giving away your proprietary information. So it's very critical that we organize information and learn how to communicate and share that information. So this is what we do. This is just a basic picture. This is not ours, but I just wanted to give a basic representation of how we organize the information and different customers can use it. So moving on, same thing with IoT devices. I mean, I love the way a lot of the people have been talking during these presentations. You're connecting with temperature sensors, weather sensors, light, everything, every aspect, whether it's in a ship or a plane or a static or a buoy, right? All of that integrates. And so we kind of provide that with, we customize that. We tie it in with Amazon. We tie it in with Microsoft platforms to kind of come up with a centralized solution to share. We also partnered with Microsoft and Okta. So there's single sign-on. So the key is when you're sharing across the board, it's very important to kind of have one login so that you have everything you have access to available and visualized. So we kind of connect a lot of the different systems and provide it. So for a project like the one we're talking about here, you have three different aspects, right? You have the planning phase. You have the current real-time phase of what's happening right now, and then what's happened. So the planning phase, you have all that data and the study and research material shared with different groups, whether it's blueprints or whatever else. Then we have the dynamic phase, the current phase, where we're tracking trucks or different kinds of vehicles. And then we are also tracking where the equipment is. And then finally the metrics at the result phase, where you need to show specific types of metrics to get the discounts. I think one of the questions you had raised before was, how do we go to the government and say, hey, that we've been saving in carbon? And we are able to show those metrics based on aggregation and accumulation of all the data sets that are shared. All right, so let's move on. So I'll just jump to the projects. If is that something that you want me to do right now, Nathan?
Yeah, just say a few words about each, Mo. Let's skim through as fast as we can.
No, take your time. There's no rush. But yeah, the projects are specific, and that's what gives the context here. So I appreciate that.
Okay, go ahead.
Perfect. So this is a global project. Once again, it's important to bring the relevance to what we're doing now, right? So if you're dealing with large number of people, as well as assets that are distributed, right now we're showing it in a global nature, but even if it's in a smaller local area, we kind of drill down or drill up, right? And this is an example of what we did for a global drill down for different kinds of. Can you actually make it into presentation mode so we can fill the screen? It's easier.
I can imagine that should have been used in a COVID scenario or a vaccination scenario, right?
Oh yeah, we did some of that mapping as well. Yeah.
Mo, can you see it better?
Yes.
Okay.
So here, what you're seeing is, I won't describe too much. Let's go to the next one. Yeah. So here, what you have is, I need to just maximize. Sorry.
Tulare Lake.
Yes.
Well, this was a project. Let me step in here, Mo. I think this was a project we did for Caltech. They wanted a tool for middle school teachers to teach their students how to record information about their environment. And it was very interesting because we had to make the system so simple that the kids could start collecting information and see and display the results. It was just amazing to see some of how the kids represented what they've discovered in their environments. It was, amazing from the perspective. Of course, before we started, we were told that middle school, the ages 8 to 11, is when students, the little kids, absorb more information than any other time in their lives, apart from, of course, infancy. But
so this was a solution that. So I don't know if any of you used. I mean, a lot of you, I'm sure you use Google Docs, right? So you just log into Google Docs and you're able to have a Word Google document that you guys are all updating, right? So we took that same idea and we dropped it into a map, right? So little kids are placing points and polygons and this is actually used by, we distributed this in FAA, right? Where multiple people are putting in things like bird strike or different kind of scenarios. And the little kids were using this and different users were logging in and adding information. So, and please, anybody, if you have questions, please stop us and we'll be happy to share.
Our whole concept was to make it so simple that you don't need to be a GIS analyst to do to map. So it really took it onto a totally different level of experience.
So the idea is that we're not just doing the mapping. This is a good segue. Keep going. Yeah. So the idea is that we're not just in GIS, right? So everybody says GIS. We've been doing GIS. Everybody talks about GIS. Been doing it for so long. We focus on the data, right? So the information that's coming in, we organize it, tag it, manipulate it, and tag it, organize it with validity and curation. go through several aspects of QC to make sure that we're able to represent that information accurately. So here is the output for some of the examples. This is we were doing campaign analysis for a local campaign. And this is the output. And you can actually click on the charts. We can show a lot of these demos, but at a later time.
Yeah, this is a dashboard, an interactive dashboard that allows us to inspect what the survey results. We have the political polls, and the results allow us. The dashboard allows us to analyze the results to make sure to determine who the demographic characteristics of the respondent and how their choices are determined. So it's a very powerful interactive tool that we have.
So here is one of our projects has been with New Frontier Data. They have a product called Equio. And what they do is they track cannabis sales nationally, as well as legalization and all that information. So once again, connecting with like 50 different databases, different sources, local, small sources of information from cities to large sources of information from the federal government, and we're visualizing this. So this is a very vague type of example, but this is actually live and dynamic. It shows where, based on one location, where all the flight paths are going. So this is like a travel visualization solution that we built for multiple government agencies. And you can pick a time range, and you could see exactly where the flights take you, and you see where people are traveling more, right? So just another random visualization, but we can only do this with quality information that is regulated properly, right? So please continue. So this is a dashboard. So whenever you have projects, so one of our state projects is, just tracking what's happening globally, where, travel warnings or whatever else, right? So this actually is a version 1. There's a version 5, which actually has video for every country. And this is automatic, right? We're not doing anything that we're touching. So all we have to do, once again, is organize information from the backbone. So multiple customers, multiple companies or organizations updating information. We organize it in Amazon or Amazon Cloud or Google or Microsoft. And that information is organized in a way so easy that it spits out a web service that we can easily visualize like this. So I'm getting into technicals, but the idea is that something like this, with the way we organize the information, takes 5 minutes to create for us. So we can customize something like this for just one city or one area, saying this is what's happening real time. If somebody comes in and asks you, what are you doing with what's your status right now? Who's where? And why haven't I received, the XYZ report, right? So you could actually visually show that. So,
yeah, the date here is 2014 because this is a static demo, but this functions real time. The moment any one of the sources changes their data, it's reflected on our database.
Yeah, I think it's also very important to note that we built a map like that in 2014. A lot of the newer mapping technologies are now kind of coming up to speed with. So we custom and fine-tune this visualization specifically to the customer. All right, so here we have work order. It's very important. So we show, so if you have logistics, it's a very critical aspect for people to get to locations on time. And so here we're showing all the different work orders and the directions and the time that contractors can go from one position to another. So this is very critical in logistics. And so I know that's a part of this project as well, where you're going to be, hey, when you're actually implementing what we're planning here, right? And so visually showing where different people are going to be at different times. And this is also a mobile solution where any mobile phone can be tracked, and the person that you're tracking is saying, yes, I'm going to be arriving very soon. And as soon as they get to the location, the work order changes. So we use different solutions that are out of the box. It's not our product. It's some of the solution. And so I can share more.
Let's just stop on this screen because I really like this. Imagine if this is not just a person, but it's a tree. And you see like this red is emergency. Like the health of that tree is in need of somebody coming to water it or add soil amendments to it or something like that. And then you're looking at all of these data points as the forest, which is the really interesting part when we talk about mangroves or we talk about other agro, forestry programs. You can add this layer on top of many different mediums.
Another possible use for this is our dredges will be equipped with GPS.
Mm-hmm.
And well, one thing, first step first, if you can provide, use satellite GIS information in a real way to provide topographical information for the Delta, which is Colorado River Delta, which is very remote and hard to get to, that would be of help. But secondly, as we deploy dredges into that area with GPS tracking, having this type of data coming into a centralized location to tell us where the dredges are, how much they've dredged, what our progress is, allows for job site planning and logistics in a more efficient manner.
Yeah, exactly. Once again, you've hit the nail on the head. It's like we're not just a visual company. We would take the information that you have and distribute it across the partner platform, right? So everybody will be able to access and use it.
Say a little about snow plows, Mo.
You have that video you can share later. Yeah, but yeah, we did that tracking. DC a while ago, had something called Snowmageddon, where they had so much snow. And so they had brought in snowplows from out of the municipality to help and support. So all they did was install one of the applications off the box and share that. We can jump this one. We don't need to share this.
Okay.
Yeah, and so we visualize that. So we did that with police as well. So fire and police. So when there's a 911 call, the fire trucks are able to see the 3D building ahead of time, the floor plan, and everything else. Also, the chart visualizes how many times they've called them and what types of emergencies they typically have. We use a lot of that stuff. We also partnered with Motorola to do the land mobile radio tracking automatically. So a lot of contractors use the land mobile radios that Motorola provides. So we easily tie it with that and track the users.
That's interesting. It's like, I think that's what, not to get on that note, but we'll go there. That's what a lot of people have been talking about with policing, right? If it was a certain type of call that comes in, maybe it's a different person other than a police officer that gets that call and gets dispatched to that because it's for a different topic. It's a mental health type of emergency. And, a system like this deploys you there. You can easily know what the floor plan is so you can go in safely because you might not have lethal force with you, right? So this is a really interesting conversation.
That's right. Yeah.
And our stuff is real time. So as a situation is evolving, you can watch the response of the first responder as he's moving into the area. And at the same time, we have information about the responder and his health circumstances also to be able to rescue him as and when it's required. We've done a lot of that work for the city of Washington, D.C. I think we have another slide on that. Mo, this is Queen Anne's County.
Yeah, so Queen Anne's County, this is what for a project called VUM, Virtual Utility Mapping. A lot of municipalities don't have sanitary sewers, right? So we provided a solution which uses satellite imagery and automatically generates satellite imagery as well as Google Streets and a bunch of other sources, and automatically generates how much it will cost to convert to a sewer system, right? And a water system. So based on houses, based on, a lot of different metrics.
Mo, can I add something here?
Yeah, please.
Typically, it would take sanitation engineers to develop a sanitation plan, maybe a month to do it for a city. Our system, once we have parcel and street centerline data, does a complete design with complete engineering specifications for every pipe, every fitting, and the cost related project cost in a fraction of a second. So
cost differential, can you share that real quick?
Well,
survey cost and
I don't think we have a slide on the budget, Mo. That's another slide.
I think he's just talking about I think he's talking about conceptually, right? That cost difference is you don't have a field engineer, you don't have a surveyor, you don't have that. That's the cost savings metrics that you plotted in an instant or a fraction of a second.
Yeah, and so just the idea is this, right? Whenever we build something, it's going into that central repository, which then communicates, right? So imagine what happens when you build a building, right? You have a blueprint that goes stale, right? Throughout the life cycle of that building, you're changing it, you're updating it, and it's evolving, right? But that blueprint still stays the same in some random location. Same thing with utilities, right? Our planned approach is then stored and then modified over time, right? And that modification goes not only to the utility, public works, right, department or public utilities department, but it's shared across the whole. So what happens, when there's the police department will use it, the real estate department will use it, all the different groups will use it, and so it's distributed across the board for the customers.
But generally, if you're building a building and you need to tie into sewer and water, your system would likely tap into the same type of information database that, let's say, Underground Service Alert would use to come out and actually physically mark where the guy with a backhoe has to be careful in digging for a pipe and other such things. So it makes your system takes all the information, puts it together, gives it to the project manager, so the project manager can call Service Alert, or maybe it does that for him automatically. So the guy that's out there on the backhoe doesn't dig into the gas main and blow up a city block.
Yeah. That's exactly right. So we have a mobile application where they go out on the field and they update the mobile application. And when they update it there, everybody gets the update.
That's tapping into a very large and sophisticated amount of information. It is 2021 though, isn't
it? But here's the secret and why, a lot of engineers are frustrated with the huge inundation of information. Our systems don't copy that information onto our platforms. It leaves the data at the source, and we tap into real-time information as things are changing. And the moment that that point in time passes, it's archived, and we don't need it anymore, unless we have to go back, and we can use the time slider to go back in time to see how things were in the past. So in reality, there's no real transfer of data back and forth. So it makes our system so powerful because the data stays in one of three locations. It changes as it's changing. We collect it from the source. That's one. it comes onto our platform for a fraction of a second, that's 2, and it gets archived, that's 3. But all 3 are available over time. So it's neat what Google has enabled us to do, and has taken GIS to a totally different era altogether.
Did you have a question about that?
About Travel Chronicles more?
Just as a person who is put in underground utilities for multiple hillside developments in Southern California, I understand the logistics help that creates. Thank you.
Yeah, that's good.
Yeah, Mo has worked for many years at the State Department in Washington, D.C. They're the largest real estate owner in the world. And simultaneously, 80,000 projects sometimes have to be managed at the same time. You can imagine the logistical nightmare they used to have. And Mo and his team on site developed this capability to share the information among contractors, among internal staff, so that everybody knows what's happening real time.
Yeah, and it's never, like you're saying, you never know what's underground. There's so many different. Yeah, and you're always learning, so it's always an evolving process, of course. So let's move on. Here's the Travel Chronicles, and we could talk about that. Yeah,
you want to say a little about Travel Chronicles, Mo?
It's just a fun project that we built with Google, where anybody can go around and use Travel Chronicles and just talk about their experiences. Initially, it was built. It was like an Instagram before Instagram kind of came up. So
it just allows you to take photographs and make notes about them, so any one of your friends can follow through in your entire tour. This is very useful also on the field, where you keep a record of all your field notes, and so that can be tracked over time of how your project has progressed.
So we're running. We're at 7:57.
Yeah. Okay.
So let's just jump through real quick.
Yeah.
This is just showing basic geolocation with everything that's in the database. We accurately plug everything. So it's not just location. We do the curation of data behind location. So anyway, let's move on.
Yeah, they are behind this. Every one of these points that you see have retail customers, and we have 700,000 data points that are being represented at any one time through drill down at capability. You want to say a little about Now Connect Mo?
Okay, yeah, it's just that's a solution I was mentioning earlier. It's just mobile phone tracking, and if you have a fleet of people, it's just tracking the entire fleet. Verizon does this. The mobile phone customers do that, but we kind of tie it in with internal systems. So
like work orders.
Yeah, work orders and other things. So yeah, Amazon also, we customize existing solutions that are already doing this. So this was built a while ago and still used by some customers. This is the JPL project. It's just NASA mapping and directly from different satellite images. This is real-time capture of satellite images, not just using existing terrain models. So we did this on the fly for some of the government agencies.
Yeah, this was for JPL, where their stream of data that's coming in from outer space, we help them create scripts to take that data automatically and to create information that wraps around the Google globe, so that you're looking at the latest information as it's being streamed in.
All right, this is on the space station. We customize this with scientists across the world.
Actually, astronauts.
Sorry?
Astronauts.
No. We customize the data with scientists that provide locations to take photographs, right? Mm-hmm. They provide the data, which we then package and send to the astronauts on the space station, right? Yep. So the astronauts, are flying around, and so you have 3 different primary windows. The main one is the one in the middle, which can mimic any of the windows on the space station, right? So whatever it's approaching from different windows. The one in the middle is actually showing a 10-minute window, what is approaching in next 10 minutes. And then the one on the right is a 2-day view, which to see if you're gonna hit the night or the day, and if you'll have cloud cover, so you can take the photographs. So this is a very exciting project. And on the left side, it also tells you what lens to use and whatever else. So,
yeah, this project has been going on for over 8 years now, with almost no maintenance required. Application has been running flawlessly over the last for the last 8 years. And we communicate with the astronauts every day. We send up the latest cloud cover that we get from the University of Wisconsin, so that they can recognize what they're seeing out of their windows.
Right, so next one is Caltrans. We're doing real-time tracking of all cars. And they just to have sensors to see what the traffic is like. So, I mean, of course you get this in Google, but how does Google get it? Google gets it from Caltrans and other sources. And we actually created the system for real-time capture of traffic in different areas.
Yeah, we standardize the software for their traffic control devices throughout California. They had a nightmare in having to maintain 6 different systems in 6 different traffic management districts. And we
So going back to our project that we're talking about here, is the reason why we're bringing these specific slides up is because it relates in some way to what we're talking about for this project, is that real-time tracking of information, organizing the data, and providing it, visualizing it, or providing it to anybody that wants to analyze and visualize it. Okay, same thing with this. This is for the presidential inauguration we did in 2009 for Obama's first inauguration. We tracked all the roads that were closed, where the issues and incidents were happening. We connected, the key here is that we connected information across local, state, federal government agencies to keep the president safe, to make sure that everybody was okay. And what ended up happening is that a lot of citizens were exhausted because it was so hot. And so we were tracking and supporting them, and we were helping the fire departments kind of find the locations where people were needing more water, more supplies.
Also in Washington, D.C., we helped them with this shot spotter application, where in seconds our systems show where a gunshot has been fired. And as you can imagine, in Washington, D.C., it happens a lot.
All right, so we have about 4 more slides, so we have to go quickly. Okay. This is for the FAA. We track all the planes real time, 10,000 plus, and each plane could be a millisecond tracking. So if you know data, you understand the complexity of how much information is coming in and how we have to organize it to distribute it across the government. This is NASA this is for the JPL rover project. This is for tracking of the Curiosity rover and showing where on Mars the rover is tracked. So we could do the same thing with anything on Earth.
Yeah, for your dredgers, for example.
This is the WISE project that we did with University of San Diego, where students would travel across to different countries, and they would take pictures and talk about what's happening. Once again, very much like Instagram, but it's being used for education. And so once the students would go out, they would provide this information back. The the professors would then use this information for follow-up generations of students to kind of travel and talk about their experiences.
And this was remote learning about 10 years before COVID.
This is for the Library of Congress. We're organizing large amounts of information, old maps, satellite imagery, and several different aspects. We actually tracked some of the Civil War and captured historic maps and information. We spoke at the MAP library in LOC. LOC is Library of Congress. And this is using, we could talk about that later. Now this is suspicious activities that happen where, somebody's got a package or something, and then and they leave it somewhere. And so when they leave a package somewhere, we capture that process of tracking. The key here is, once again, communication across the different government agencies, so that it's not verifying to make sure that it's not a bomb before somebody acts on it, right? So, or something that would harm different groups. And if it's something that's suspicious, then we automatically notify Verizon or a company or an organization about that. Hillsborough County, we tie in with 911. We just map out and visualize what 911 calls come in to help them, once again, support them in their tasks. All right, so that's about it. The key here is that, if we can go back to the top, I think the central image that I want to just kind of portray is slide 6, which is, the goal for us is not the analysis, but connecting the dots between different groups and providing the reporting in a way that you're going to be able to go after, ask the government for carbon credits, or organizing the data so we can analyze it, or reporting to investors saying that, hey, you paid us money, here is what's happening now. And we've organized all our partners, we've organized all of our data, and we're not just reporting bad information. Here's the clean, accurate data organized across different vendors that you can use. And at the end of the day, also taking that organized information, whether it's from the partners that we have for this project or the government satellite that everybody has access to, like Google, to show the 3D images, or traffic data, organizing all of that to kind of, handling operations.
Yeah, and I think you summarized that. You have the forward-facing platform that's for the community. You have the behind doors application for your internal partners, and then you have the kind of gray area where you're reporting back to state or federal government agencies. I kind of see this as that is the blend, because a project like this is kind of a private and public partnership kind of development, where you want that real-time data of dust emission tracking or fuel consumption or carbon sequestration able to be published at any given moment throughout the day.
Yeah, there are two aspects to what you just said, Nathan. One is the drill down capability. On a federal level, there are 3 levels basically in government: local, state, and federal. There's different kinds of information created and communicated at each level, and the most detailed level is down at the local. Not all of that information is at the state level. And finally, on the federal level, they really want to have an overview of what's happening all over the country. But when there's a crisis, they should have the capability of going to any one point and drilling down all the way to the local level to find out what's causing a problem.
Can I show my screen, if you don't mind?
Yes. I'm going to stop sharing here, Mo.
Yeah, I just want to share it real quick. I just want to show you guys that, it's not just static images that we're showing. that everything that we showed you has a real-time view. Real 1 second. Share screen. Oh, can you share? Can I share my screen? Or do we have to go?
No, take your time, Mo. I was just going to say something like the importance of that health, life, and safety concern. When a sensor starts to notice that there's a dust storm occurring, that's the really interesting part about this. There's activity to probably a text alert, kind of similar to an amber alert, that people are aware where that dust is coming from, when that dust is going to arrive, what they need to do to prepare, get all of the information. If you don't have all of the things that you need, here's where you get that information. So I see that kind of overlay when it comes to just this overall region as a health and life safety kind of issue.
You're on mute. Can I share my screen, Nathan? It's blocking me for some reason.
Real quick, if you have the ability to track dust, do you have the ability? Probably got a whole bunch of recorded water vapor transport from the Southwest. Over time, it may be beneficial to the project to track any increases or decreases in water vapor emitted from the Salton Sea region and going into the Colorado River Basin.
Yes, we should be able to. We don't build the sensors as such, but we can take information from the supplier of that data and display it in the manner that Nathan just referred to. There's a difference between. I'll give you an example. In the state of Louisiana, we had a situation where we were building a classified globe for internal government management, for the governor's office, in fact. And it was for emergency response, from the planning, real-time situational analysis, and then prediction of what's going to happen. So all of a sudden, we had the oil spill. And they came to us with the request that we create, because, there was a lot of criticism that the government wasn't doing enough to respond to the crisis of all that oil contamination in the ocean. And actually, the government were right on the ball at that time. So in less than a week, we created a globe for the public to see how the government was managing that particular aspect. And over 2 million viewers were watching the moment-to-moment evolution of that oil spill and how it was spreading. It was a significant, we got a lot of recognition both from Google and the government in Louisiana for what we did at that time. So, it's information like you're talking about, where your sensors are going to provide us the information that needs to be disseminated, but we need to know who needs to see what and provide the information to those windows.
I'd also like to add to that, the sensor information is very important. Everybody talks about sensors and information, but we've noticed that the curation of data from different sensors is very important, because not all sensors and the types of sensors provide accurate information, right? So tracking of that with machine learning and just large data sets, checking to see what's providing quality information and the brands to buy and the way to set them up is a very critical factor. Depending on the sensor, the quality assurance is very critical.
Yeah, you're showing the video, right, Mo?
Sorry?
You're showing the video, yeah. You want to say a little about it? Talk a little about it?
No, I mean, we talked about all of this. I don't want to talk.
Yes. Well, this is literally some of the applications, being, we had a record of while the application was working on developing.
Yeah, once again, the GIS and visualization, it's very easy. But the complicated parts for us is that we have to organize that information and validate it, and share it, distribute it. So that's where we focus on more than anything else. Just wanted to share that bit.
Thank you, Nathan. I think we went a little way beyond our time.
No, there's no time limit on the importance of what you're mentioning. I mean, all of this is critical, and that's why we're kind of have this open platform. We have a buffer zone in the morning and the evenings to go over critical items that need to be discussed. Because I mean, the applications that you just said, it looked like you had a couple nuclear sites, right? Like that's kind of the, I don't want to get beyond our capacity because we're focused on this region, but we're really talking about over this 3-day course is these are global applications, right? The most critical information is real-time data.
Yeah.
Yeah, once again, we didn't want to go outside of the scope, and every aspect of what we're doing kind of applies to that local information and the operations side of what you're trying to do. So.
Yeah, and I can imagine that overlay. I mentioned it yesterday just jokingly, but like if you had to include some robotics into your system, some robotic dogs or some robotic helpers, those are tied into the system as well as the employees. I just really like the idea of showing, because we have this waste conversion component of this where we can take waste plastic and make fuel, but showing that system has probably 100 different layers just within the building, the infrastructure, but also all the products coming in, all the products going out, all the employees in, all of the emissions, like all of those facets become a building related project related to your company, but the input outputs, then they have their own product that are tied in, because the fuel that then goes out to the dredge, the fuel, you're going to track that until it's gone, and then you're going to say, where does that dredge go to get its refueling station? And all of the embedded energy is what we would want to take this project forward with, because that becomes, are we doing it with less, right? Is a system that does the Laguna Salada restoration more environmentally friendly than a perimeter lake, right? That's the same thing that we talked about with a regional climate model of just water precipitation. You need to know that before you even get started. What are the cost benefit analysis, and how is this more environmentally sensitive and beneficial than the alternative?
So you've got brilliant scientists here, and you and Rob, the way you're communicating about these things it's something that, I mean, a lot of aspects of this we don't know, right? But what we do know is that organizing of that information, it has to connect, right? And that metrics, we work with you directly to kind of compile.
The whole organization has to be such that it appears very simple on the surface. Although there's so much information, it's very easy to get overwhelmed. So that's what we do.
Yeah, I mean, the question is, why not just use a Google Drive? Everybody throws their files in there. It doesn't work that easily, right? So, because you have two people doing a survey in 2 different areas, you're providing similar information. You want it visualized in one place. You want it analyzed in one place, but people are putting files in different places, right? So how does that even get? That's a basic example.
Yeah, and also nobody needs to see everything.
Yeah.
There's, everybody has a particular perspective, and we have to organize our systems to allow them to see just what they need to see.
Well, so I love the idea of this when we talk about islands, and like we mentioned at the onset of today's event, the New and the Alamo River, tracking the trash that goes in and pulling back and going upstream to know where those points of pollution are coming in. And then you can track the water quality and actually show, I love the visualization of those water sensors that show the red, like the emergency. And over time, the entirety of the river slowly starts to change colors, right? And then eventually that becomes your paradigm of, this is what it was day one with one island, and then we had 50 islands, and we had 1,000 islands, and you show over the course of 5 years what happened, and then you can correlate that with the soil, sediment, carbon sequestration, all of the components, and then more importantly is the jobs, right? The people that are actually being employed by those systems being being able to come from the factory where the product's being produced, the delivery to the sites, the installation, the maintenance and operation. That kind of data is a gold mine because it shows where the economics are actually being deployed. And funny enough, if we actually pulled that back and studied Salton Sea administration, I don't even want to go there. But if you study something and get that critical, where you try and track where those things got you, you would see that there wasn't the application as it results to on the ground deployment. And that's kind of where we want to cut that straight in half and say, we're an open book. As a project manager, we're an open book. We're always going to publish this not only to the public, but we're gonna mirror that at the 3 levels of government, like you mentioned. This information shouldn't be veiled because it shows how the system is performing, and that's the valid approach of moving it forward. It's a fact-based approach as opposed to the illusions, right, that we're used to seeing.
Yeah. And this is a very sensitive area you're working in. You have to be very cautious what information you're propagating, right? So
we
have to work very closely. Yeah, you have to work very closely with the 2 governments, and that's what we specialize in. Working with government, observing their norms and conventions, and making sure that no one steps on no one's toes. And
even more importantly is the habitat too. Like you just mentioned, that the government is very critical, but when we talk about fish, bird, new whale species, if we can track that and have that element and that overlay, you can show the real-time data as the evolution is in place.
Mm-hmm. You know what Street View is, right? Mm-hmm. Google Street View allows you to see what is on 2 sides of the street. We developed a platform called Stream View for USGS, and that's exactly what we did. The entire habitat of the river was being tracked, as Mo will show you, along the river, the observations by the team. And this was a huge cost saver also, because instead of people going out and inspecting things on the field, they could review all of the data as it was on the platform, just sitting in the office. So it was a huge cost saver also.
Well, using that same thing, USGS streamflow data, it is helpful. I've already archived decades of USGS streamflow inputs into the Salton Sea. Mm-hmm. It would be interesting to be able to continuously track that through the future, because there are a lot of ratios, like the size of the salt sink and other such things, that depend on that type of data.
Yeah.
Well, I have to say this has been an amazing exploration of not only the United States, but around the world and to the moon and Mars. So, and I just wanted to say too, I think your name is on the Mars rover, is it not, Swapan?
Oh yes, our signature's on the rover.
as it's walking around and rolling around Mars. That's pretty exciting.
We happened to be working at JPL just a few days before the actual launch. So right up to the day of the launch, they were accepting signatures to go onto a micro disk.
Well, if you're going to build a habitat on Mars or do terraforming on Mars,
I'd love to work with
materials that are there, right?
If someone knows Elon Musk, I'd love to work with him on doing that.
Well, all I'm saying is we're terraforming a place where there is literally unlimited supplies of silt and sand.
Uh-huh.
How well can we utilize that resource to do what we do without importing rock or concrete or this or that? Right. How much can we just use what's there?
Yeah, already, yeah. And
is that a NASA philosophy?
Yeah. Well, it is. Years ago, we installed a 3D printer on the International Space Station. That's really what is required, a basic 3D printer to do all the to implement all the architectural work, on Mars. So you can take what is available locally, feed it into the printer, and manufacture whatever you want to manufacture, prefabricate it. So,
Right.
NASA is thinking about it, and they're amazing. They use high school students to work on projects like this for a very simple reason. You and I are not going to be going to Mars, but those kids, when they grow up, probably will have a much more probability of them traveling to these places. So, in a sense, you're training them from now to do what they'll be doing maybe 2 decades later.
Yeah, well, and the idea too, I think when we talk globally, I really like the idea about tracking and tracing sea level rise as that's coming in, as I'm sure you guys have been involved with Google Earth. I'm sure most of the images that we see are probably from your office, but tracking that, and then projects like this where you're doing depression restorations and you're actually bringing in ocean water onto these land masses and tracking that, as well as the precipitation around the globe, how that actually affects it is really kind of, that's what we're talking about as a holistic kind of vision of how we kind of take climate change on from the onset without having some preconception. It has to be a solutions-based approach, and it has to have a scientific background, and it has to have the data. And the data is the facts, right? There's no contesting data, and there's no contesting information. So that's a great prelude to wrap up this day. Thanks for bringing us the facts, Swapan and Mo.
Gabby got the message.
Oh yeah, Gabby, please, let's see what we have. You can unmute yourself if you want to ask.
I just did, yes. Thank you. This was great. I can just imagine with visualization such as the stream flow, incorporating data from the simulation studies of what would happen in the regional precipitation in a sort of forward-looking view, as you have on the space station. This is what you see now, this is what you'll see next. Yep. If you can incorporate a visualization of the data, that will help politicians who don't listen so well, but at least they can look and get an idea. It would help a lot.
Yeah. And we have the spokesman, Mike Waters. Mike Waters. He has been nominated for the Emmy, I think, about 40 different times. And he's a really good broadcaster. And he's in Washington, D.C. He works on a lot of our videos, and he's very convincing.
Now, we could do it the same way. And you know what? I think we've got good people on this team, right?
Yeah.
Where we can help provide the data, and we can all visualize it or analyze it in a different way. And then we put it together and produce something,
Yeah.
Right. And maybe send that note to the space station on accident, the coordinates for Laguna Salada. You take a picture here on this day. I remember just a quick story. I remember when I did a visit, it was supposed to be the hottest day at Laguna Salada. And I just saw the clouds and the jet stream going over. It was a thick, dense wall of clouds that were gray. And that was going to be the hottest day, but it was going over the Mexicali area. But right when we drove into the Laguna Salada Basin, there was no clouds at all. It was a straight line over Eagle Mountain. So you can see directly the effects of not having water, and then of the water that is in the Sea of Cortez moving over that region. So it was really dramatic. And right when the sun broke through, it was a hot day. But before that, it was the perfect day.
Yeah.
Heck, just actually having satellite data of the process of the first inland sea to flood with seawater since the end of the last ice age, having that and putting that out, if we can get, guys, this is spectacular. This is a once in a 10,000 year event. It's the first one. There may be more to follow. And that's what we're hoping to set the kind of the groundwork for on how to get it done.
I mean, for example, speaking of politicians, Wade Crowfoot, the head of the California Natural Resources Agency, just celebrated the water they were bringing to the Salton Sea to maintain a donut-shaped wet spot to keep the dust from blowing around. He's the person who needs to see what putting more water could do in terms of bringing regional precipitation, what bringing more water to the Laguna Salada and the Salton Sea could do. And the simulations will create that data. And there are similar scenarios in the Sinai that the European Commission and WETSIS, it's the water campus in the Netherlands. There are several different projects that are on the same track that are all using that same kind of WRF simulation. Perhaps they could be synthesized to boom, boom, boom. It's not just the Caspian Sea, it's this, to kind of emphasize that it's not one-off, but the effects of adding moisture can really engage. You've got a shallow sea, you've got very warm sea surface temperatures that can help lift marine layers, that can convect monsoon moisture when it's there. If you let it dry up, you're not going to convect it. Just some quick this or this kind of visualizations will help clarify the opportunity.
Right, and I've personally met Wade Crowfoot. He's a very intelligent guy. He's very in tune with science. The new administration at the state level, Governor Newsom, they are rational thinkers, and we're proposing and we're doing this presentation and this open discussion for those people to engage with. So, and this is a discussion which you just mentioned. This is an opportunity for United Nations to take a look at what opportunities there are for climate change. There is a solutions-based approach. It doesn't just have to be the problems or disaster relief, but more than that, it's looking at the Salton Sea as $33 to $70 billion for inaction, or $1 billion for full restoration of both of those areas. That's a fraction. That's 5% the cost. So, when you take those at a global level, trillions of dollars for inaction on climate change, or the hundreds of billions of dollars to do projects just like this, it just doesn't. There's no competing factor, and that is United Nations level. That's a presidential level. But the discussion that we've been outlining here is regenerative agriculture and other farms, real-time data mapping, and just taking that and putting the political spectrum in it. It's a win for everybody. Nobody loses in that situation. It's good for economics. It's good for the job creation. This is what pulls us out of a COVID recession at a global level. So we're excited to have you here, Swapan, Mo. It's always a pleasure to have you guys. I'm really grateful for you stepping in, and we're excited to work with you guys in the future. We're going to jump in. I guess that'll wrap up our day. We went a little bit long, but we're going to wrap up with a little bit of music now